All right, this is day 2, solving direct and inverse problems. We are going to first just talk about in generalities. What happens if y varies directly with x? If x is doubled, what happens to y? So basically, remember how if one goes up, the other one goes up? Well, if one gets doubled and goes up twice as much, the other one should also double and go up twice as much. So quick and easy answer is it doubles. I want you to be able to see that and use that without having to do a lot of complicated equations. If x is multiplied by 4, what happens to y? So if we have an x and we have a y, and one is 4 times bigger, the other one should also be, guess what? 4 times bigger. So it's going to be quick and easy, 4 times bigger. All right. Number 2, if y varies inversely with x is doubled, what happens to y? So if x gets twice as big, remember, as one goes up, the other goes down. This one should also get twice as small. So it's actually going to be cut in half or 2 times smaller or 2 times less. Okay, either way you want to say it. 2 times less is still the same thing as cut it in half, so it's going to be half as big. All right. Part B, if x is multiplied times 3, what's happened to y? So x is going to be 3 times bigger, so y should be 3 times smaller. So 3 times smaller is the same thing as 1/3 as much. Okay? You're going to see the fractions used more often than you're going to see the 2 times smaller or 3 times smaller. Pretty quick, pretty easy. Now, I want to talk to you about different ways to solve. Yesterday we did the steps. Okay? Step 1, write the generic equation. Step 2, these are on the front of your board in the room. They're also in your notes. Find constant k. Step 3, put constant k in your equation and use the equation. So we're finding a constant and we're using the equation. That will work every time, all the time. It's very structured. It's very meticulous. It takes you through steps. There's also an alternate way to approach direct variation problems. And there's also something to keep in mind with inverse variation problems. So on day 2, I'm going to take a second look at some direct and inverse variation problems. Direct variation problems can be solved by setting up and solving a proportion. You will need to cross multiply to finish the solution. Proportions involve usually 2 fractions. Can have many fractions, but you only have to have at least 2 fractions where they are related in a particular way, but they're also matching fractions. All right, so I'm going to use my first sentence. If you want to have a highlighter, the distance a spring stretches varies directly with the amount of weight hanging on it. I know it's going to be the distance it stretches. Directly is important, and the amount of weight that's on it, or hanging weight. So it's still going to be distance and weight. Distance was mentioned first, and weight was mentioned second. So I'm going to use a fraction with distance over weight, which coincidentally would give you constant k if you were going to solve with constant k. This setting up and solving a proportion takes you straight to the answer, but doesn't necessarily stop to give you the constant. All right, my second sentence, again, the weight of 2.5 pounds stretches the spring 18 inches. 2.5 pounds stretches the spring 18 inches. So if I set up a proportion, I can set it up any way I want to. I just simply started off with D over top of W. So the distance it stretches would be 18. The weight is 2.5 pounds. So that is my first fraction. I got that from the 2 pieces of information that work together. So 18 is to 2.5, and now here's the key. Now you're going to put in equals, and then you're going to focus on what is it I'm actually looking for. Find the stretch in a spring when 6.4 pounds is hanging on it. 6.4 pounds is hanging on it. So now I'm going to set my second one up that matches my first one. Remember, I chose to do distance on top, W on the bottom. It doesn't matter. You could have set it up the other way, still would have given the same answer. So you could have said 2.5 over 18. That would have been W over D, and that would have been okay to start that way. It doesn't matter how you start. It just matters that when you set up your second one, that you set it up the same way. Find the stretch on a spring when the weight of 6.4 pounds is hanging. So in this case, 2.5 was a pound. So that means 6.4 has got to go to the bottom. And 6.4 would be on the bottom. Find the stretch. So the distance that it stretches is letter D. This is what I was looking for. Okay. So we could say 18 inches of stretch for a 2.5 pounds weight is equal to how much distance of stretch to 6.4 pounds weight. Okay, that's basically what we're doing. This only works for direct variation. If you had done the other one, you could have also done it this way. I simply would have had equals, and 6.4 would have went on top because this is 2.5 pounds and this is 6.4 pounds. Okay, however you start your first fraction, your second fraction has to match that same pattern. So 18 inches of stretch, and now I'm looking for D, how many inches of stretch. All right, so now it does say you have to cross multiply. So if you're rusty on cross multiplying, you're going to multiply across the equals. So that's 18 times 6.4. These two numbers are multiplied together, and I'm going to put my equals, and then these two are times. Well, 2.5 times T is 2.5 D. Now, if I solve for letter D, I know what I'm going to end up doing is have to divide by 2.5. So now I'm going to take my calculator and I'm going to type in 18 times, whatever's on top goes in your calculator first. So 18 times 6.4, and then I can just go ahead and hit divide by 2.5 all at one time, and the answer is 46.08. Was not a nice, neat, perfect answer, but still a very reasonable answer. Okay, so if I notice that this is direct and it does match, my weight increased, not quite 3 times as much, but it increased. So my distance of stretch is also going to increase, not quite 3 times as much. All right, so solving by setting up a proportion is an alternate way to do direct variation. Again, this only works with direct variation. It does not work if it says inverse. All right, the second one I want you to pay attention to is where it says inverse variation can be solved by multiplying multiplying to find the constant and then dividing. That always seems to be the pattern. So it's really not a trick. It's just shortcutting the steps to where they're super quick and simple. All right. When we did our steps yesterday, we still looked at the first sentence and we still realized the time it takes to milk cows varies inversely, so the time it takes inversely with the number of milking machines. Okay, so the more milking machines cuts the time down. So from that relationship, I know pretty much that it's inverse, and so we know that time is going to be equal to something over the number, and we talked about solving for constant K. If you will remember, what we did is we multiplied to find the constant. 8 milking machines can milk all the cows in 2 hours. So to find constant K, we said 18 times 2. Got an answer of 36. Now from this point, it does not matter how it sets up, no matter whether you put the number it gives you to solve, whether it goes in place of N or if it goes in place of T, you'll always end up dividing. So I know I can actually come right here and say divide by the next number. Divide by the next number. So it says multiply and divide. When you multiply, you're getting the constant. When you divide, you're solving and using the equation. So I'm going to say divide by 5, and that's my answer. And I think that gives me 7.2. All right. Again, notice that with this is inverse. This only works with inverse. So let me make sure that we all see. With inverse, this is inverse only. This is actually abbreviation. It's just cutting to the chase. It's really the same thing as the steps, but you're not writing everything down. Pretty much. You multiply first. Okay, if you can just memorize this, it always works. And when I say multiply first, you're going to have to multiply the two numbers that go together. So multiply first the two that go together. Okay. In this problem here, it said it took 8 milking machines 2 hours. So the 8 and the 2 went together. So I multiplied those first and I got 36. Then it says it's for inverse only. This is for inverse only. Okay. It only works for inverse. So after you multiply the 2 that go together, then what you're going to do is you're going to divide by the next number. Okay. So this only works if it's just inverse. Please don't do this for direct. So inverse only, multiply the first 2 that go together and divide by the next. All right, if you ever view this or want to view this on the computer, when it's not today in class, you can always pause and go back. Okay? All right. So I'm going to go back and review. Number 1, you can do the steps. Okay? We did the steps yesterday. That's 1, 2, 3, 4. They're in the front of the room. Write a generic equation. Find constant k, put the constant in there, use the equation to solve. There's also alternate ways to solve. There's a way to solve direct by setting up a proportion. Okay? Setting up a proportion. If you know how to set up a proportion, then you can set up for direct variation. Some people find that easier. Some people don't. If you don't like a proportion, it won't work for you. You can go back to the steps. But you have to be able to cross multiply. Inverse variation problems, this is really not an alternate solution. It's just a straightforward, matter of fact, go straight to the answer because this is the steps, really quick and simple. Multiply to find the constant. When you do that multiply step that I talked about, multiply the first ones, the 2 that go together, you're actually getting the constant at that time. All right. Then dividing. So you're going to divide by the next number. You're going to divide by whatever comes next in the problem. It just always works. All right. Now that we've done a couple of those, we're taking a second look. Again, see if you can work out the next ones. 5 and 6 are on your own. Okay. I'm going to ask that you pause the video, take a minute to see if you can solve, and then we'll start the video after everybody has a chance and see if you were able to solve it correctly. All right. Did you figure out that this one was direct? Because this is one of those where it does not say. So you have to figure out. This is talking about on a map. So if you measure out 4 inches on a map, and that's a certain length, then you measure out a different number of inches on the map. Do you expect that to be bigger if it's a bigger number of inches, or do you expect that number to be opposite? Hopefully everybody can figure out that that's direct. This would be an example of a problem where they're not going to tell you. They assume you can reason it out. So this is direct. So I simply went with what I saw first. I saw 180 miles represents 4 inches. So I did 180 miles over 4 inches. So then the next part says how many miles are represented by 6 inches. How many miles are represented by 6 inches? I have miles over inches, miles over inches. Here's my x. So I can abbreviate this. 180 over 4 is equal to x over 6. If you practice proportions enough, you can go straight to them. I think this is a little easier. If it's not easier for you, you can go back to the steps. So when you cross multiply, it's 180 times 6, because these two have to be multiplied. Set that equal to these two multiplied, 4 and x. I'm going to go ahead and solve this for x. So I'm going to divide by 4. That way I only have to pick my calculator up one time. If you type it in as 180 times 6 divided by 4, hopefully you got 270. So my answer is actually 270 miles. So if I draw with this scale, that's pretty much what it gave you. It gave you a scale of 180 miles for every 4 inches. That's 270 miles for 6 inches. And that's actually what you do. You're saying it's 180 is to 4 inches as how many miles is to 6 inches. So setting up a proportion takes you straight to an equation. Again, if you want to continue with this section of the video, I can show you how to solve it the other way. Okay, for those people that would like to refresh from yesterday. So in this problem, we know they're directly related. So the number of miles is directly related to the number of inches on the map. So I can say the number of miles is directly related to the number of inches on the map. I guess I'll use letter I. Okay, and I'm solving for constant K. So in this case, the number of miles is 180, or to solve for constant K, it's going to be the miles over the inches. So it would have been 180 over 4. That's actually what I started with. Okay, I just didn't actually stop and pause to get there. So I got 180 divided by 4 is 45. So now I know that my miles is equal to 45 times however many inches it turns out to be. Then it says how many miles are represented by 6 inches. So the miles is equal to 45, and then the inches would be 6 times 6. Guess what you turn out to get? 270. Notice that we ended up, we divided by 4 and times by 6. If you follow here, 180 divided by 4, and then we times by 6. We're still doing the same thing that we do if we do it the other stepwise way. We're just able to set it up in a slightly different fashion. So these are all of my steps. 1, 2, 3, 4. Okay? Again, just visiting an alternate way to set up and solve direct problems. Number 6, time varies inversely with speed. See if you remember the pattern. There is a pattern to every inverse. So first, time varies inversely with speed. Okay, so as long as I know it's inversely, time varies inversely with speed. So I know there's constant K. I know what the equation is, but if I want to shortcut this, I'm going to go ahead and say, you know what? 4 hours and 80 kilometers are together. Those two numbers are together. So I'm going to say 4 times 80. How long does it take at 64 kilometers per hour? So what if we change the speed? So how long does it take at 64? We're going to divide by the next number. Okay, so you multiply the two that go together. Okay, you multiply the two that go together, and then you divide by the next. So 4 times 80 divided by 64. I get 5. All right, so let's just see if that makes sense. How long does it take? It must take 5 hours. Okay. If I had not done the shortcut, I would have said, okay, constant K is 4 times 80. So I'm pausing to get 320. And my time is equal to 320 when I put in my constant over the speed. And then I have to realize that it says how long does it take if it's 64. So 64 turns out to be the speed. So it's 320 over 64. So I ended up, to get this number, I had 4 times 80 divided by 64. The answer is still 5 hours. So this is a second day, day 2, looking at it from a new perspective. All right. At this time, you have a chance to practice. There are some cards around the room. There are 9 cards. You must do all 9 cards. This is around the world. So the problem on every card has an answer on a different card. When you go to that card, that different yellow card, that's your new problem, and you keep going until you've went to all 8.